Okay, this is regular physics, uniform circular motion. Problem assignment, page 173, number 55. All right, the problem describes a car traveling around a flat circular track. You're given a coefficient of static friction of 0.4. You're given that the curve is a radius of 80 meters. And you're trying to find out is how fast can the car go around this curve safely without skidding. All right, so here we have my cool Formula One racer thing here, going around this curve right here of 80 meters. Okay, so this is a top view. And so my tangential velocity is this way, and since I'm turning, I am going to have an acceleration in this direction, which means I have to have an F net in that direction. All right, so to do my free body diagram and make it look a little bit better and easier to understand, let's look at this front view then, all right, with this cool car coming straight at us then. And I know that it's kind of coming out of the paper, but all right, it's making this turn then to the right. Okay, so I'm going to need an F net in this direction. Well, my free body diagram tells me I've got a weight going down, and I need to be in equilibrium in this dimension, so my force normal, its magnitude, has to be in equilibrium with the weight. Okay, the force applied by the engine to drive the car forward is coming out of the paper. That's not pointing towards the center of the circle. So it's in a different dimension. So it's not going to be part of my problem. All right, so what's left over? Well, perpendicular to the plane of contact, I have force normal. Parallel to the plane of contact, I have force friction. You should be going, oh, gee, this is just like one of the practice problems I had. Yep. All right, so when I go F net is equal to mass times centripetal acceleration, there's only one force out of all of our four forces left over that's pointing towards the center, and that's force friction. Okay. Now, force friction, then, we know is mu static force normal, mass acceleration centripetal, that's tangential velocity squared over the radius r. Okay, this is the guy that we're trying to get after. And there may be some mass whining, but let's explore force normal a little bit more carefully. Mu static force normal, I know its magnitude. It has to be in equilibrium with the weight. So the weight is mg then is equal to mass v sub t squared in the numerator divided by radius. So that means that the mass will cancel out. So this has been given. I know this. I know the radius. I just need to solve for this speed or this tangential velocity. And that's all there is for this problem.